This is pages 46 to 49. The data that needs to be used for this present is included in the lab. In order to determine if the reactions occur, you'll use the activity series, and I'll show you all of this when I do the detailed lecture. Activity series and the cell simulators provide them detail. I'll show you how to use them. I'll show you what you need to do with that. And you need to see if those reactions actually occur. If they do, you'll see changes, and you'll record those changes in your observations, because you'll see the exact same thing you would see if you actually did this. Okay. You can use the data document, and it will give you results that somebody else has gotten, so that should confirm or deny whatever you saw. There is titration data provided because there is a titration component in the redox. So there's a titration that's been done. You'll need to balance the redox reaction for the titration in your lab. Okay, so there's that. Go. The summary, as always, the objective is on page 46. Equation number 2 is the one I asked you to balance in your lab notebook for the pre-lab for the experiment. Calculate the mass of each aliquot using the density. Calculate the mass of the H2O2 in the dilute sample based on the titration data and the balanced chemical equation. So information will follow, I promise. This calculation is done for both trials. The original concentration is found by multiplying your result by 10, because we've diluted this by 10. So we need to make sure that we calculate the original concentration. We want you to calculate the percent error based on what this solution was supposed to be. So even though it isn't anymore, we're going to calculate a percent error based on that. We want to know, is your data accurate? So how close is your answer to the real one? So if it said it should be 4% hydrogen peroxide, how close to that did you actually get? How precise is your data? So do your two trials match each other, or are they variant? Because that tells you how precise they are. What are your sources of error? Be specific. There are any number of things that may have gone wrong with this. I don't care what you tell me as long as it makes sense. Okay. So as long as you've thought about the physicality of what you're doing and it makes sense. That's good. Now, why do we store H2O2 in the dark? Why do we do that? And what does light do? How is that involved? And why is that important in what we're doing here? So I want you to do some speculation, some Googling perhaps, of why that's the case there. And that's what you see. So there's the summary. As far as the post-labs, did the 4 reactions that actually occurred, what are the net ionic reactions? Okay, so there are 4 that actually happen, the rest of them don't. What are the net ionic reactions for those? Did your predictions match the reality? If not, why not? What do you think you could do to help you determine if that's going to happen in the future? I want you to use your data to predict the reactivity for Ag, Cu, Naz, N, and H. And then I want you to add strontium to that list. Okay. And how do you decide where to put it? What factors did you need to think about to decide where it needed to go? I want you to use the electromotive series from the lab manual to determine which reaction should occur. Identify the net ionic equations for the 2 that did happen. Identify the oxidizing agent, reducing agent, number of electrons transferred in the titration. And again, specifics will come in the lab. Okay. So it's a lot of repetition about what we're doing. There is an activity series, which we call the electromotive series. It's another phrase for it. That you'll be using for this particular lab. We want you to be able to use that data and work with it. Okay. So that's everything I have for that particular experiment. So I'm going to close out here. I will be back with you extremely soon. I have lecture 8, lecture 9, lecture 10, and experiments 6, 7, and 8 to record for you to get to you this week. So hopefully we'll get with that. Stop sharing that. Stop my recording. Talk to you guys soon.